Today, we're going to start making an ice shader in Unity and Unreal. Let's go! So we're going to start out in Unity today, and then I'll jump over to Unreal and show you how to make the ice shader there as well. The property of ice that we're going to be working on today is refraction. So you can see that I've got this ice shader that is refracting the background behind it. There's some other properties of ice as well that we're going to also add to our shader, but that'll be in next week's tutorial. All right, so we're going to start out today by right-clicking down here in our project and picking Create, Shader Graph, HDRP, Lit Shader Graph, and we're just going to call this shader Ice. All right, so I'm going to double-click my shader, and we're going to jump right into it. So the first thing that we need to do in order to create our refraction is we need to bring in the scene that's being rendered behind our ice. Actually, you know what? Let's do one thing before we even do that. First, we need to set material surface type from opaque to transparent. And the reason that we need to do that is not because we're going to make our object transparent with alpha, but because we need the object to render after the scene has rendered so that we can use our scene data to refract. And I'll get into more of that in a minute. So we've got our ice shader here. We set it to transparent. And now you can see there's this alpha value here. And normally when I create a transparent object, I would use this value to determine how transparent the object is. And I'll show you what we get if I set this to like 0.5 and we save our shader. Let's assign our shader to this rock in the scene. So we'll grab our ice material here and drop it into the material slot on our rock. Okay, and now you can see that because I set my alpha value in the shader to 0.5, I have an object here that is half transparent. But the thing about this kind of transparency is that there isn't any refraction. So what I want to simulate here is I'm looking through the object, and the light that's passing through the object to me is getting bent as it passes through. What I'm seeing here now is the light is just passing directly through, and there's no bending happening. So we want to simulate refraction. And an easy way to do that is to use the scene color node. So let me show you what that does. I'm going to add an HD scene color node here. And this is going to sample from the screen using screen space coordinates. So these UVs here are the coordinates on the screen. So it's by default, it's just set for each pixel on the screen is going to sample the scene itself. So if I wire this into base color, and it's also really important to click this exposure box here. So when I wire this into base color, what we're going to see is, well, actually, I'll just save it and show you what we're going to see. So now what you can see is through the back of the rock, we can see the rest of the scene. And that's because the rock is taking on the color of the scene. So I'm using the scene itself to render for the color of the rock. So that's pretty cool, but there's one thing that I can do that will kind of help to show this off. We have this value here called LOD, and currently it's set to 0. That means it's sampling the scene at full resolution. But the higher I set this value, the lower resolution version of the scene we're going to be using. So I can actually blur the scene and make it look like the scene is getting blurred through the rock. So if I set this value to something like 5, for example, we're going to be using a really low resolution of the scene to show what happens through the rock. So now it looks like the rock is actually frosted because we're using a low resolution version of the scene to show what's behind it. Our scene color map, and you can almost see the pixels here as we zoom in because the resolution of the scene that we're sampling is so low. But what it does is it makes it feel like our rock is volumetric and it's sampling and the light is getting scattered as it passes through the surface to make what's behind it look blurry. So that's a pretty cool effect. Now, the next effect that we need to do is actually create some refraction. So just so that we can see things better, I'm going to set our LOD back to 0 so it's full resolution. And to do refraction, what we need to do is alter the screen position before we use it to sample our HD scene color. So if I just pass scene position directly into HD scene color, that's the default even without it connected. And so this is not going to change our result. But if we alter our screen position before we pass it in, we'll be able to change the coordinates that we're using to look up our scene color value. And that is how we're going to simulate refraction. So first, let's see what happens if we just add a hard-coded value to our screen position coordinates. I'm just going to add a value of, say, 0.1. And we'll see what happens when we offset our screen position coordinates by 0.1. Okay, so now what you can see is happening is that our screen is shifted by 1/10 of the size of the screen. An interesting feature of that is up here at the top, we're getting some smearing because this portion of the screen is off screen and it doesn't exist. So we just have to take whatever's on the edge and stretch it. So we've taken our screen and shifted it down by 1/10 of the size of the screen. And we've also shifted it over to the left. And you can tell that because we're seeing this rock here in the ice when it doesn't actually line up. And so we've added this 1/10 of the screen offset to our screen texture. And we're getting what sort of looks like refraction because our rock doesn't line up here. But it's not exactly what we want. We want to kind of simulate the effect of light bending. And what we've done here is just take the scene and offset it a little bit. So what we need to do is come up with a better way of calculating this value here that we're adding to our screen position. The first thing that I'm going to try is using the normal of the rock. And to do that, we'll just add a normal vector node. But by default, the normal vector is in world space, and what we want is for it to be in view space. And so what's going to happen here, we'll be offsetting our scene color value using the direction that our rock is pointing. So you can see when the rock is pointing straight at us, there's going to be no offset. But as it shows around the sides, it's going to be there's going to be more offset. So let's first try plugging our normal vector here and adding our normal vector to our screen position coordinates and see what happens when we do that. All right, cool. So now we're definitely getting refraction, but I think this refraction is a little too strong. And we can tone it down just by adding a multiplier. So I'll switch back to my ice shader here. Here's my normal vector. And right now I'm just going to multiply it by 0.05. And that's just going to reduce the strength of that refraction quite a bit. All right, so I've toned down my refraction. Now you can see that the light is getting bent as it passes through my ice. And it's starting to look like realistic refraction because we're warping the screen coordinates that we're using to look up the scene color using the direction that the rock surface is facing. And that's a really nice effect. The other thing that we can do to make this look better is to use the normal map that's intended for this rock object to also perturb the surface. So let's add a sample texture node, sample texture 2D, and we'll bring in the rock's normal map. There it is right there, rock A normal. And we'll set our node to be a normal map. And now what we can do is just add our normal map together with the normal vector here. And you can see that's giving the normal vector some more bumpiness. And now I can pass that into my multiply to tone down the bumpiness and then use that as our refraction. Okay, so now you can see that there's a lot more detail happening in the refraction. The edges around this rock that I'm seeing through the ice are all broken up because we're using that normal map to give additional offsets to our refraction. That's pretty cool. All right, so let's add just a couple of more touches here. We'll switch over to our ice shader, and I'm gonna grab the results of my normal map here, and we're gonna pass this into the normal input here in the master stack so that I can get the normal showing up on the surface. Also, I'm gonna set my smoothness to 1 here, so we'll have a nice shiny, smooth surface that you would get if the ice were wet. And then finally, I think I'll set my HD scene color here to 3, so we're not completely blurring the background or what's behind the ice, but just a little bit to make it feel like the ice is scattering the light as it passes through it. All right, let's save it and take a look at our final result. All right, now you can see that I've got a really nice piece of refractive ice. We can see through the ice and it's kind of blurring the objects behind it. And we're using the normal map from our mesh to add detail to the refraction as well as to add detail to the surface. So that's pretty cool looking. Now there are a lot more effects that we can add to this. One of the properties of ice, and this is something that I've showed in a previous video maybe 2 years ago, is that ice is volumetric and it has details that you can see on the interior of the surface. And so that is what we're going to cover in next week's video. I'm going to show you how to add details inside the volume of the ice. And that's going to be pretty cool, so be sure to come back next week for that. But before that, we're going to switch over to Unreal, and I'll show you how to make this same refractive ice effect there. All right, here we are in Unreal, and you can see that we've created the same kind of an ice shader here that we did in Unity. So let's go ahead and create that shader, and I'll show you how it works. Open up my content drawer here, and we'll right-click and create a new material, and we'll call it ice. And we'll open up our material and get started. Okay, the first thing that we need to do is we need to come over here to blend mode, and instead of opaque, we're going to set our blend mode to translucent. Then we need to come down here to our translucency settings and set our lighting mode to surface translucency volume. These are the settings that we need for creating our ice shader. Okay, and then just like we did in Unity, the first thing that we need to add to our shader here is the scene color. So I'm going to add the scene color node, and I'm just going to plug it directly into base color, and we'll take a look at our result. So now you can see that I'm sampling the scene color. We can see the background behind our display sphere here, and that's because this is the background color, and we're just using that to shade our model. Then the other thing that I want to do just quickly is add a constant value here and set this to our roughness. So we're going to make our surface completely smooth, and that way you'll be able to see some reflections in the surface of our model as well as to be able to see through it. Now, the next thing that we need to do is offset the coordinates that we're using to sample our scene color so that we can create some refraction here. So in order to do that, I need to add the screen position node. And this is the node that uses the screen position for UV coordinates. So you can see I've plugged that in and I'm getting the exact same result now as I was getting before I plugged it in. And that's because scene color uses screen position by default as an input. But now that I have this screen position node, what I can do is add values to it to offset those coordinates before I use them to look up my scene color. So if I just add, let's add like 0.1 for example, now you can see that the screen is offset by about 1/10 of the total screen size. So it no longer matches up here, it's being pushed up and to the left. So I need to use this add value, but instead of a hard-coded value, I need to use something that makes sense for the amount of offset that I actually want for each of the pixels so that I can simulate refraction. So in order to do that, what we can do is bring in a vertex normal node, and the vertex normal in Unreal comes in world space, and we actually want this in view space. So I'm going to add a transform node. And we want to transform this from the world space that it's currently in to view space. So I'm going to set the source to world space, and I'm going to set the destination to view space. So we're transforming our vertex normal from world space to view space. And now we can take that and add it to our screen position. Our screen position is a vector 2 or a float 2 value. But our vertex normal world space is a vector 3. And so that's why we're getting this error here. You can see it says invalid input types float 2 and float 3. This is a float 2 and this is a float 3. And so we need to mask it out so that we're only taking the first two components. So we're going to add a component mask here. And I'm just going to take the red and the green channel and plug that in. All right, now you can see I'm getting some insane amounts of refraction. And the reason for that is the range that I'm getting here is from -1 to 1. And so we're just refracting all the way across the entire screen. And so I need to take the value here and tone it down a little bit. So I'm just going to add a multiply. And we'll multiply it by 0.05. Just to weaken the amount of offset or the amount of refraction that we're getting here. So if I plug this in, now you can see I'm getting refraction, but it's just ever so subtle instead of being really strong. And I can increase it if I set this to like 0.1, for example, and now it's a little bit stronger, the refraction. Okay, let's go ahead and take this ice shader that we've started and add it to the model in our scene and see what we get. So I'll just take my ice shader and drag and drop it right onto my rock mesh there. Now you can see that our rock mesh is refracting the objects behind it, and it looks pretty cool, but it's kind of lacking in detail, and what's missing is the normal map that's intended for use with this rock. So let's go back to our shader and add the normal map in. And this is something that you'd want to expose in a parameter if you were creating this shader for production. But because we're just using this as an example today, I'm not going to expose all the parameters and that kind of thing. All right, so I've added my texture sample here. And now I'm going to add T rock mesh normal. And I'm going to plug the normal into the normal input socket on the root. And I'm also going to add the normal to my view space vertex normal here, and we'll use that as our refraction vector. So I'm adding the normal map values together with the vertex normal here, and then we'll pass that in. And now you can see the refraction that I'm getting is influenced both by the vertex normal and also the normal map detail. So I'm able to get a lot more detail here than I normally would if I didn't have that normal map texture. That looks pretty cool. So if I save this now and we switch back to our scene, you can see that now the normals on the surface of the rock are being used to refract the data behind it. That's a pretty neat looking effect. So we could use this for a simple ice shader, but we're not going to stop here. Next week, I'm going to show you, just like I said during the Unity portion, I'm going to show you how to add internal details to the ice so that it looks like there are volumetric effects going on inside, even though the mesh itself is just a simple shell. In the technique that we cover next week, we're going to show you how to create details on the inside of the ice. And we might add some other items just to kind of polish up this shader. All right, I hope you enjoyed today's video. Be sure to give it a thumbs up if you did, and I hope you have a great week.